Okay, we're starting the Unit 6 section. Unit 5 was all unit circle values. Pretty much prepared to do that without a calculator, of course. Make flashcards if you need to. You guys are good with those, though. We've been practicing those all along the way. Here, for the domain of arcsine, arccosine, and arctangent, remember for arcsine, you're looking at quadrants 1 and 4. And quadrant 4 is where your angle values are negative and your values are negative. So that would be negative pi over 2 to 0. And then from 0 to pi over 2 is where you pick up positive arcsine values. For cosine, you're looking 0 to pi. Using all positive angles, and from pi over 2 to pi is where you get your negative values. And for arctangent, you're using the same domain as sine, from negative pi over 2 to pi over 2. And then you'll use those for, make sure you use those for your unit circle values for arcsine, arccosine, and arctangent. Just make sure you're restricting those domains. You'll only have one answer for a question like, what is arcsine of 1/2? You're not looking whole unit circle, you're just looking first quadrant, fourth quadrant. And make sure you do those negative values. Okay, these two are triangle problems here, 3 and 4. Remember, you use the inside value to set up your triangle. That's all the inside is for. And if everything's positive, then you want to set it up in the first quadrant. So, uh, 12, if we're working with sine is opposite over hypotenuse. So our opposite is 12, our hypotenuse is 13. We need to find our other side, so we're going to use the Pythagorean theorem. Or if you have that special right triangle memorized, that's awfully helpful as well. Otherwise, you can do the math. Perfect squares up to 15 are awfully helpful for if you would not have a calculator available. But those aren't too unreasonable. So your missing side is 5, and we needed that missing side so that we could do cosine, because cosine is adjacent over hypotenuse. So cosine of this angle, which is why we set up that triangle, is adjacent over hypotenuse. So 5 over 13. So this whole thing is equal to 5/13. And you're done. Similar situation with arccosine, or tangent of arccosine of 7/25. Again, it's a triangle problem. We use the inside guy here to set up our triangle. So cosine is adjacent over hypotenuse. This is also a special right triangle, and you can solve for the missing side if you would like. I will tell you that it is 24. You can do the Pythagorean theorem, absolutely. And then tangent is opposite over adjacent. So this whole thing is equal to 24. So, knowing those special right triangles is helpful. Really 5, 12, 13, 3, 4, 5, 7, 24, 25. There are a couple more. If you're interested in those, Googling, you can just Google special right triangles and it'll give you those ratios. Although you can always do the Pythagorean theorem as well. All right, that is your the inverses portion. Just make sure, again, that the most important thing here is to make sure you know these unit circle values with the restrictions. Remember, you're only going to have, if we're asking for whole unit circle, you're going to have 2 values. If we're doing our inverses, you're going to have 1 value, and you need to only look in those quadrants. And for sine and arctangent, or arcsine and arctangent, if you have negative values, you need negative angles. All right, I hope that helps.